Okay guys, here is another problem. This is from section 2.1. This is number 13. This is dividing complex numbers. So dividing numbers with the imaginary number I. In general, the rule is we can't have imaginary numbers in the bottom of a fraction. Okay, so that's why the dividing comes, we're not really dividing in the sense that 8 divided by 2 is 4 and it's that easy. It's more about rewriting this fraction so that there are no imaginary numbers in the bottom. So let me write it down. So we have a trick that we use anytime we're trying to get rid of the imaginary numbers. We multiply by the conjugate. So if I want to get rid of the imaginary number in the bottom, I'm going to multiply by the conjugate, which means I change the sign. If I want to get rid of the imaginary number in the bottom, I multiply by the conjugate. Now, I can't just randomly do that, so I'm going to multiply by the same thing in the top. So what that does is 6 minus 7i over 6 minus 7i is really just multiplying by 1. And I'm allowed to multiply by 1 because 1 doesn't change anything. Multiplying by 1 keeps the same value. So that's why I'm allowed to do that. So this is going to involve lots of distributing or FOIL or whatever it is you'd like to call it. You need to multiply the top times the top, and you need to multiply the bottom times the bottom. Okay, so let's do this in blue. For the top, I've got 1 times 6, which is 6. 1 times negative 7i, negative 7i. 3i times 6 is 18i, and 3i times negative 7i is negative 21i squared, I times I being I squared. So we're going to simplify that in just a minute. Doing the bottom, I have 6 times 6, which is 36. 6 times negative 7i is negative 42i. 7i times 6 is positive 42i. So if you notice, those are going to cancel out. That's why this trick works. Multiplying by the conjugate, your inner and outer terms always cancel, and that's how we get rid of the I. So then 7i times negative 7i is negative 49i squared. So if we start simplifying these, negative 42i and positive 42i cancel. I squared in both cases is negative 1. I squared is equivalent to negative 1. So we'll keep that in mind. So right now we have 6. Negative 7i plus 18i is 11i. And then negative 21 times negative 1 makes it plus 21 over 36. And then negative 49 times negative 1 is positive 49. So 6 plus 21 is 27 plus 11i over 85. Ooh, I hope I did that right. Okay, so the last thing we need to do is write this in standard form. Do you guys see this? This is where if you ignore what my math lab says in the directions, you're going to get it wrong and you're going to get frustrated. It says express the result in standard form A plus BI, which means we need to write it as 27/85 plus 11/85I. Okay, do you see that? A plus B I. If this reduced, we would simplify it, but I'm pretty sure it doesn't reduce. We're going to have to check. If it does reduce, then this will mark me wrong, but I'm pretty sure it doesn't. Let's see. We all know I've been wrong before, so. And I, you can just type I. You don't have, there doesn't need to be a button for I. And there we go. That's it. So yeah, if those fractions were able to be reduced, you would reduce the fractions, but in this case they don't. That's as simplified as they get. Okay? Make sure you pay attention to the formatting that my math lab is asking for, or you won't get full credit. All right, let me know if you have any questions.